In addition to adding, subtracting, multiplying, and dividing functions, we can actually do this thing called composition of functions. So the composition of the function f with the function g, it's written like this, and I'm going to write it a little bit bigger. F we'll do in blue or red, g we'll do in green again. So the notation that we're going to use looks something like this. So f, and it looks like the word, sorry, I'm just color coding it. It ends up kind of looking like the word fog, where f is composed of g. What that really means is we're going to take function f, and instead of plugging in some values for x, we're going to plug in all of the function g of x. Now, if we plug in something for x inside of g, we're going to do whatever g does first, apply whatever g is saying, get a number, and plug that into f. Now, this visual here is a little confusing, but let's talk about it. So the domain f composed of g is the set of all x in the domain g such that g of x is in the domain of f. In other words, it's got to be an x value that gives you an output in g, and that way we can take that output and put it into f. So it's got an x value that needs to work in g so that the output, so like say for example g of 2, maybe it gives us an output of 7. If that 7 works in the function or domain of f, then we're good to go. Don't worry so much about that right now. We're going to practice this a little bit right down here. So f of x equals x plus 2. Again, doing that in red. G of x equals 4 minus x squared. It says find the following and state the domain of the final composition. So the first one, f composed of g. So again, just like I said in the part above it, we're going to do f composed of g of x. So the way I read it is f of g of x. In other words, we're going to plug in g of x in for the x's in f of x. So let's start writing out x plus 2, but instead of x, we're going to replace the x. So we're going to replace x in f of x with all of g of x. So instead of plugging in a value for x, we're actually plugging in a whole separate function. So instead of x plus 2, let's see, we've got f of g of x. Instead of x plus 2, we're going to replace x with all of g of x, which was 4 minus x squared. And then keep that plus 2. So again, we just replaced the x with 4 minus x squared. Now we're going to clean that up a little bit because we have a common 4 and common 2, so we've got 2 common terms there. Putting this in standard form, f composed of g of x equals negative x squared plus, we got 4 plus 2 would be plus 6. So we plugged in function g into function f. Now for the next one, it's going the opposite direction. Instead of g composed of, or f composed of g, we're doing g composed of f. In other words, we're going to take f of x and plug that in to g of x. So g of, and let me write this in the kind of a different notation as well. So essentially instead of x, we're going to replace it with x plus 2. So originally g of x was 4 minus x squared, but now it's going to be 4 minus replacing x with x plus 2 squared. So we're replacing x with x plus 2. Now we're going to clean that up a little bit. I'm going to switch to blue because now it's going to be a combined function. We got 4 minus x plus 2 squared really means x plus 2 times x plus 2. Then we got to go through and distribute that. We have 4 times, or sorry, keeping that minus. X times x is x squared. Keep this in parentheses because we're subtracting 4 minus whatever the result of this multiplication is, whatever the product of this multiplication is. So we got x times x, which is x squared. We got x times 2, which is 2x, but then we're also going to have another 2x right there we go. So we're going to have a total of 4x because of this 2x plus this 2x. Then we're going to have 2 times 2, which gives us 4. So now we got 4 minus everything in parentheses there. Now I know some people like to distribute the negative. I'm just going to kind of go through and do 4 minus x squared minus 4x minus 4. Then we're going to combine some like terms. Well, the only like terms we have are, well, this 4 and this minus 4, which are going to cancel each other out. So at the end, we're going to end up with g of f of x equals, well, after this 4 and this minus 4 cancel out, we're left with just negative x squared minus 4x. Last one of this type, letter C, we're doing g of f of negative 2. So this time we're actually going to plug in a value to kind of show what it looks like. So again, using this more familiar notation, we'll do g of f of negative 2. So we're going to plug in negative 2 into function f first. So I'm going to leave the g outside alone. So f of negative 2, this guy right here, means we're going to plug in negative 2 into the function. So it'll be negative 2 plus 2. So we plugged it into function f. So g of, well, negative 2 plus 2. We got g of negative 2 plus 2 is 0. Well, g of 0, now we can plug that into 4 minus x squared. So we get that's equal to 4 minus 0 squared. Let me switch colors there to make it a little more consistent. Okay. So now we got f of negative 2, whatever the result is, we now plugged it into g. So we end up with 4 minus 0 squared is just 4. Sorry, I'm off the screen. Let me shift a little bit. So g of f of negative 2 simplified down to just give us an output of 4. Down at the bottom, those are what we're calling compositions. This one is kind of going in reverse. You could call it decomposition, which kind of sounds a little bit morbid. But we're given a function h of x. We're going to see if we can break it down into two separate functions, f and g. So taking a look at h of x, we've got h of x equals 3x minus 5 to the third plus 1. What I would do is just kind of look at, like, well, what's inside of a group? Do we have any clearly defined groups already? So I'm going to say that f of x, actually let me switch colors. Let's call this 3x minus 5 its own function. So we'll call f of x 3x minus 5. Now the outer stuff, I'll call the other one g of x, is kind of like what would happen if we replaced that 3x minus 5 with just x. We'd be left with x to the third plus 1. So again, it's kind of like we take this guy and plug it in for that x to give us that group right there. So I'm going to say, this case, h of x equals g of f of x. We just kind of broke it down into smaller pieces.